Hello, Advanced Math Trig students. If you are in Honors Advanced Math Trig, mods 2, 3, and 4, today is Friday, May 1st. Unbelievable. May 1st, 2020. So again, if you're in mods 2, 3, and 4, top left corner of your paper, for your notes, you're going to put the date 5/1/20, Friday, May 1st. If you are in Advanced Math mod 7, you're doing the same topic, same material, same questions. It's just that your date should be, I believe, Thursday, May the 7th, 2020. So top left corner of your paper, if you're in mod 7, it'd be 5/7/20 for the date, okay? The title for all of you, Sigma Notation. Probably something brand new. The word sigma is simply a Greek letter. It's a Greek capital letter that looks like a giant, almost like an E. I guess that looks like a giant E, kind of fancy. So the Greek letter that looks like an E is a capital letter called sigma, and it's a notation or a symbol that's used in a lot of math situations, mostly in statistics for next year, that always represents a sum. So guys, the second you ever see a math formula with a capital letter, that Greek letter sigma, your brain is thinking, oh, I'm going to sum together a bunch of stuff. I'm going to add some things together. It represents a sum, okay? Now, it's going to look really strange at first, but if I just looked at example number 1 here, I'm going to cover up number 2 so you don't look too far ahead. Look at the first example that I've got on our paper. So go ahead on your paper, write that Greek letter sigma. Underneath it, put I equals 1 up to, and on top is the number 5. The 1 and the 5 could be any two numbers they want to use. Usually the bottom number is either a 0 or a 1 to get you started. This top number, in this case it's a 5, it could have been a 6, it could have been a 13, it could have been a 50, it could have been an infinity symbol. But bottom line is, you've got a number that you're going to start with and plug in for the letter in your formula first. And you're going to keep plugging numbers into your formula until you finally plug in the top number, which is your stopping point. So guys, bottom line is, when you see the Greek letter sigma, you're going to start or begin by plugging in the number that you see at the bottom and plug in each successive number until you finally have plugged in the number at the top, which will be your ending value. So, translation into English. If I told you to solve this problem, because really you're going to sum a bunch of numbers together and give me a final answer here. Oh, watch this. Look, it says I equals 1. So you're supposed to take that bottom number 1 and go plug it in for that I in this formula. Well, obviously, if I plug a 1 in for I, 2 times 1 is what? 2, plus 1 creates the number 3. Automatically, because that letter sigma represents a sum, you are going to put a plus sign and then go and create your next number by plugging in a 2 this time. Well, 2 times 2 is 4, plus 1 is 5. Again, put a plus sign because it's a sigma symbol and it means sum. Well, I've plugged in 1, I've plugged in 2, now I'm going to plug in 3 for the letter I. 2 times 3 is 6, plus 1 is 7. Plus, now I'm going to plug in 4. 2 times 4 is 8, plus 1 is 9. Plus, now I'm going to plug in 5. Oh, and this will be the last number I plug in because it's the number at the top of my Greek letter sigma. I start with the number on the bottom. I keep plugging in numbers until I finally plug the number in at the top. So if I do indeed plug that 5 in, of course, 2 times 5 is 10, plus 1 is 11. And now when I sum these numbers together, I don't think we need a calculator. 3 plus 5 is what? 8 plus 7 is 15. Plus 9 is 24. Plus 11. Oh my gosh, the answer to that crazy looking problem is 35. Okay? Now, obviously, this letter, this sigma, gets introduced at the end of this current unit, because if you look at what we just created and I told you to describe it, first of all, it's finite, isn't it? It ends. It doesn't go on forever. And all they're doing to create the next number is what? They keep adding 2. So would you agree that that is an arithmetic sequence, actually an arithmetic series, right? Because there's plus signs in the middle. An arithmetic series whose common difference is 2. And when I add those 5 numbers, I get 35. I do get a partial sum from that, or a full sum. Okay? All right, question 2 looks like this. Oh man, I've got my Greek letter sigma, so they want me to sum all the numbers I'm going to create by plugging in a 1, then a 2, then a 3, then a 4, etc. until I plug in 13. Okay, now don't panic. I know that seems crazy because you got to plug 13 numbers in. But guys, really you don't, do you? Because watch what happens. You're all trained now in this chapter to look for patterns and have formulas to work with, don't you? Let's see what happens here. If I take 1 and plug it in for k, 3 times 1 is 3, minus 1 is 2. Plus, all right, you always put a plus because that symbol itself means to sum. It's a sigma symbol. Now let's plug 2 in. 3 times 2 is 6, minus 1 is 5. Plus, there's no pattern yet. Let's see what the next number is. We did 1, we plugged in 2, now let's plug in 3. 3 times 3 is 9, minus 1 is 8. And just for good measure, if I went one more time here and plugged in a 4, 3 times 4 is 12, minus 1 is 11, plus, now guys, I've only used 4 of them, haven't I? And I was supposed to go all the way up to 13. I sure don't want to plug in 9 more numbers here. I'm going to be here forever. Oh, so think about it. I've got 2 plus 5 plus 8 plus 11 plus ... It keeps on going. If I finally did plug in our 13th number, right? I plugged in 13. 3 times 13 would be what? 39 minus 1. I'd eventually get to 38 with a lot of numbers in between there. Okay? So in essence, since we plugged in everything from 1, 2, 3, 4, etc. up to 13, aren't I finding the sum of the first 13 numbers of this sequence? And it's pretty obvious that this is a what? Talk to me. Describe it. Isn't this an arithmetic sequence whose common difference is 3, or in this case, an arithmetic series whose common difference is 3? Oh, so I want to find the sum of the first 13 numbers. I've got a formula for that, don't I? Isn't the formula to find the sum of the first n numbers of any arithmetic series really what? Does anybody remember? I'll give you a second to think about it. Does this look familiar? It was n times a sub 1 plus a sub n all over 2. Remember that formula when you had to go off to the side and do some chicken scratching just to get the a sub nth term? Well, watch this. Obviously, I'm looking for the sum of the first 13 numbers, aren't I? So 13, s sub n is 13. So this n is 13. In parentheses, I need a1, the first number. Well, let's look. What is the first number? 2 plus a sub 13. Well, we already know if I did go way down and find the 13th number, it would be what? We already did that. 38 all over 2. So obviously I have 13 times, do what's in parentheses first. What is that? 40 all over 2. I'm going to cross out the 2, change the 40 to a 20. So we take 13 times 20 and get 260. I just saved myself a ton of time by not only understanding what the sigma symbol means, but realizing that that was an arithmetic series and I could use my partial sum, my S sub n formula from an arithmetic series. So when you go back and try some of these tonight, if you're noting it on your paper now, fine, or you might have to go back to your notes and look up a formula just to recall what it was to help you out, okay? Again, if you didn't remember that formula, I guess you could have written all 13 of those out and then pulled out your calculator and started adding them all. But I'm pretty sure you'd agree that this quick shortcut was a lot quicker than doing that. Okay? All right, number 3, let's go to the next one. I've got my sigma symbol. N goes from 1 to 7 of that little expression right there. Okay, rather harmless. Here we go. N equals 1, so I'm going to go plug 1 in for that N. 1 minus 1 is what? 0. 2 to the 0 power, anything to the 0 power is always what? 1. Plus, now why did I put a plus? It doesn't say so. Oh, because it's the symbol sigma, and it means to sum a bunch of numbers together. So I always put a plus between each term. I've already plugged 1 in. Now I'm going to plug 2 in. 2 minus 1 is what? 1. So 2 to the first is 2. Plus, now let's plug 3 in. 3 minus 1 is 2. 2 squared is 4. Plug 4 in. 4 minus 1 is 3. 2 to the third, careful, is 8. Plug 5 in. 2 to the fourth is 16. Plug 6 in. 2 to the fifth is 32. Plug 7 in. 7 minus 1 is 6. And 2 to the sixth is 64. So in essence, that's the series we just created. And would you agree if I add all those up? 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, plus 16 is 31, plus 32 is 63, plus 64. I chose to write all of them out because there was 7 of them, and that wasn't horrible. And we ended up with 120 for the sum of all those numbers. Obviously, I hope it's obvious, that ended up creating a what? Isn't that a geometric series, right? Whose common ratio was what? 2, wasn't it? I took 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, etc. So the ratio was 2. The ratio was 2 for that geometric series. Speaking of which, look at number 4 here. Oh my gosh, I got the Greek letter sigma. I'm summing together all the numbers I create when I plug 0 in for m, then 1 in for m, then 2 in for m, etc. until I finally plug in 6. Now I'm kind of thinking I'm not sure I want to do all those numbers here. Let's see if we can see a pattern. All right, don't panic the first time you try these. Take 0 and go plug it in for m. Anything to the 0 power is 1. Times 3 is 3. Plus, now plug 1 in. Well, obviously 3 halves to the first is 3 halves. Guys, what's 3 times 3 halves? Wouldn't that be 9 halves? Plus, now plug 2 in for m. Now careful, 3 halves squared. Now careful, that means 3 halves times another 3 halves, which would be what? Thinking with me, 9/4 times 3 is 27/4 plus, now guys, I've only plugged in 0 and 1 and 2. Do you want to plug in 3, 4, 5, and 6 and keep creating yucky numbers here? I doubt it. And let me give you a little hint. All that is a dot connection there. Obviously, we're multiplying by 3 over 2 each time. Watch. What's 3 times 3 over 2? 9 over 2. What's 9 over 2 times 3 over 2? 27 over 4. So do you agree that this is a geometric series whose ratio is 3 over 2, correct? Oh, and I want to find the sum of the first n numbers, don't I? Who remembers the formula to find the sum of the first n numbers of any geometric series? You thinking? Do you got it? It was this one here. Does this ring a bell? A sub 1 times 1 minus r to the nth all over 1 minus r. So for this particular problem, again, I didn't want to keep on writing out 4 more numbers that were going to be big, yucky fraction type numbers. Don't panic. Use the formula you've been taught. That's why you were taught them. The sum of the first, okay, freeze guys, careful. Most people would write 6 down here. Oh, we're plugging in 0, then 1, then 2, then 3, then 4, then 5. So because we started with 0 and we're going to stop when we get to 6, wouldn't we have ended up creating 7 numbers here that we would add together? We're taking the sum of the first 7 numbers, right? Because when we plugged 0 in, we got that. We plugged 1 in, got that. Plugged 2 in, got that. We still had to plug in 3 and 4 and 5 and 6. Oh, so the sum of the first 7 numbers would be, okay, what was A1, the first number? Well, let's look. What was the first number in our series? It was 3 times 1 minus, what's our ratio? 3 halves to the nth power. Well, this was S sub 7, right? So it's to the 7th power, all over 1 minus 3 halves. So let's see if we can do this. We've got 3 times 1 minus... Now, guys, you got to take 3 halves and raise it to the 7th power. So I'm grabbing my calculator. Obviously, this is in fraction form here. So if I'm taking 3 halves and raising that fraction to the 7th, I'm going to do 3 raised to the 7th and get 2187. And then I'm going to do 2 to the 7th. 2 raised to the 7th gives me 128. All over, what is 1 minus 3 halves? Well, 1 minus 1 1/2 is negative 1/2. I'm not panicking here. Do what's in parentheses first. Isn't that going to be 128 over 128? Oh, gosh. So 128 over 128 minus 2187 over 128 gives me, this is going to be 3 times, okay, I'm going to do 128 minus 2187, and I'm going to get negative 2059 over 128, all divided by negative 1/2. So, oh, sorry, there you go, guys. Can you see it? I took 1 minus 2187 over 128. So that 1 was 128 over 128. And 128 minus 2187 gave me negative 2059 over 128. Divided by negative 1/2 is really times negative 2. Agreed? So really, oh my gosh, my bottom number is 128, but since I'm timesing that by negative 2, I can cross cancel the 2 and change that 128 to a 64. And you agree that a negative times a negative is a positive. So all I got left to do in my calculator is hit 3 times 2059. Boy, wasn't that fun. Giving me 6177 over a common denominator of 64 if we would have worked those all the way out. Ugh, but correct, okay? If you got to rewind a little bit and go back over how I did that, that's fine. It's just crunching basic numbers, okay? Careful there, obviously. All right, and the last thing we do, if you look at number 5 here, this doesn't seem right, does it? We're supposed to sum together all the numbers I create when I plug in 0, then 1, then 2, then 3, and I keep plugging in numbers how long? Oh my gosh, for infinity. So if we're really going to sit here and do this, this is basically all you're going to do now the rest of your life, because it says keep going forever and never stop. Obviously, we're going to look for a pattern and use our brains and our formulas and see what we can come up with here. So stay with me. Don't panic here. Ready? Everybody take 0 and plug it in for n. 1/2 raised to the 0 power is what? 1. Make sure you're thinking with me. Plus, now let's plug 1 in. Obviously, 1/2 to the first is 1/2. Plus, plug 2 in. Plug 2 in. What's 1/2 squared? Careful. 1/2 squared means 1/2 times 1/2, which is 1/4, plus one more time. If I plugged a 3 up there, if I took 1/2 and cubed it, 1/2 times 1/2 times 1/2 is 1/8, plus, now we're supposed to go forever, aren't we? Well, we don't have time to go forever. We're going to go dot, 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 and we're going to talk to ourselves about the series we just created. This is okay, follow the bouncing finger, an infinite series that looks like it's what? If you had to describe it, isn't it geometric? This is a geometric series that's infinite. And the ratio is what? Aren't we multiplying by 1/2 every time? Oh, and what did we learn in yesterday's notes? That if there's an infinite series that goes on forever, even though it goes forever, we can add all the numbers together and get a sum as long as it's geometric and the ratio is equal to 1/2, right? And to find the sum of that whole series, which it wants us to do because we were going for infinity, find the sum of the whole thing, the formula, remember, was a over 1 minus r. I'm sorry, a1 over 1 minus r. Well, a1 is our first number, which is 1 over 1 minus, what was our ratio? 1/2. So I've got 1 over 1/2. So it's really 1 times 2 for an answer of 2. Oh my gosh, who would have thunk that if you looked at that problem, you would do the work and the answer to that problem would just be good old 2. Pretty cool. Finally, last one of the day, number 6. Hang in there. Oh, it looks like that. If I started generating this sequence, plug 0 in for k. Anything to the 0 power is 1 times 4 is 4. Plus, plug a 1 in. 0.2 to the first is 0.2 times 4 is 0.8, plus plug 2 in. 0.2 squared would be 0.04 times 4, 0.16, plus dot, dot, dot. Guys, and again, my hint is, look, that's probably a ratio of 0.2, isn't it? If I took 4 and I times it by 0.2, 4 times 0.2 is 0.8. 0.8 times 0.2 is 0.16. So this is a geometric series whose ratio is 0.2, which is less than 1, meaning this infinite series of numbers actually has a sum, doesn't it? And to get the sum, we're going to take a1, the first number, which is 4, divided by 1 minus r. And since r is 0.2, that really gives us 4 divided by, what is 1 minus 0.2? Isn't that 0.8? So I'm going to pull out my calculator because we actually want a decimal this time, don't we? 4 divided by 0.8 gives me, oh my gosh, exactly 5 for the sum of that infinite series. Okay? So that is sigma notation. You'll see it a lot when you take a statistics course either next year or any time in college. Most majors that you take, you'll have to take a stats course, and that sigma symbol will be popping up all over the place to represent fancy formulas and summations of things you got to do, okay? When you add up a bunch of data. All right, that took a while, sorry, but that's the end of that unit. That wraps up our sequence and series chapter. Homework would be 6 problems like I just did. So hit pause and copy down all 6 of these and give me a final answer or a final result of what you get when you sum together the numbers of each of these series. So basically, again, what we're going to have, I believe, is 2 arithmetic series, 2 geometric series, and then 2 infinite geometric series whose ratios are going to be less than 1. So you can use your A over 1 minus R formula on those, just like I did. So those 6 closely mimic what we just did in our notes, okay? If you're in advanced or honors advanced math, mods 2, 3, and 4, since today is Friday the 1st, you got all weekend and Monday morning to work on that. So that is due on Monday the 4th at noon. If you're in Mod 7, this is one of your last assignments, seniors in that class. This would be due tomorrow on May 8th at noon, and try to get me the sums for these 6 series, okay? Great job. Way to hang in there. We'll see you later.